Hello everyone, welcome to my channel Quotation again. In this video, we are going to discuss about bitwise operators in Java and how to use them. If you have not subscribed to this channel yet, please do me a favor and hit the subscribe button. Let's start. Bitwise operators, as the name suggests, it allow you to manipulate individual bits in a value. This is very important that it is used on an individual bits of a value. It is not applied on the complete or the whole value. And these are used in embedded systems such as maybe tape recorder, coffee machine, something like this, which due to memory constraints or due to some other reason is dependent on the individual bits for controlling of some functions. It is also used for manipulating large amounts of binary data such as image, audio, video. Then there are 7 types of bitwise operators. 6 of them are binary operators. One is unary operator. What is binary? What is unary? We already covered in the last video. You can have a look if you have still some doubts or let me know in the comments. Now, bitwise AND it is a binary operator, so there will be 2 operands, and it will give you a value whose bits are turned on only if both original bits are turned on. Now, what are these both original bits? These are the bits of the operands. So suppose if you have 000 and 111, then take the first position of both the operands and then apply this bitwise AND. It will give you a value whose bit is turned on only if both the original bits are turned on. What is bitwise OR? It will give you a value whose bits are turned on only if either of the original bit are turned on. So it will give you a like false bit or a 0 bit if both the corresponding bits in the operands are 0. Now bitwise NOT, it will flip all the bits. So this is simple. Then there's a special XOR bitwise operator. It is similar to OR, but I'll tell you the difference. It will give you a value whose bits are turned on only if exactly one of the original bit is turned on. So this is important, exactly one. So suppose you have 2 operands whose bits at one particular position are 1 and 1. Now this bitwise OR will give you 1, but bitwise XOR will give you 0. Then there are 3 shift operators: left shift operator, right shift operator, and unsigned right shift. This is unsigned right shift. Now shift means like you are multiplying a number by a power of 2. Right shift is you are dividing a number by a power of 2. So if you do a left shift, it will mean like sign bit might be. Now there's one thing more important, that in this binary numbers, the leftmost bit is considered as a sign bit. Now when we do shift left, then the values of the bits are shifted on the left hand side. So this can cause a change in the sign bit because our sign bit is positioned at the leftmost bit. And when we shift values on the left hand side, you have to fill something on the right hand side, and we do padding with zeros. Now with shift right, when you do this right shift operator, sign bit does not change. When we shift the bits by right, we will put the sign bit on the left position, and thus the sign bit will not change. For unsigned right shift, what we do, when we shift the values, we pad the left hand side with zeros, and thus the sign bit might change. So this is the theory part. Let's quickly jump into the practical to understand these operators in more detail. Okay, now let's quickly start with the practical for bitwise operators. Let me take 2 binary numbers and how we define binary numbers in Java. What we can do, I can prefix the number with 0b. So then it will treat it as binary number. So let me take the first number as 0100, and let me take the second number as 1101. So now it will treat them as binary numbers because I'm prefixing the numbers with 0b. Let's say give this print statement, but this also, like when we will perform this bitwise operator, it will cast it into, like it will treat it as integer. So let's print the actual binary number of the result. So let's say b1 and b2. Okay, now we have two binary numbers B1 and B2. Let's perform bitwise AND. What bitwise AND does, it will give you a result whose bits will be turned on when both of the bits in the operands are 1. So if we see these two operands B1 and B2, where we have a position where both of the bits are turned on, it is the second position. So first is like this 0, and in B2 it is 1, so it will give as 0. But if you see the second bit, both of the bits are 1 in B1 and B2. So it will give as 1. Similarly, see the third bit, it will be 0, fourth it will be 0. Why? Because this bitwise AND gives if both the bits are 1, and you see only one position where both the bits are 1. Let's run our code and verify if this is indeed the result. Yeah, it is 100. Actually, this first 0, it will truncate because it thinks, okay, it's an initial 0, I'll remove that. The actual value, it will treat it as 100. If the result was 1 here, it wouldn't have removed it. Okay, now let's see bitwise OR. What does bitwise OR say? Bitwise OR say that it will give the result whose bits will be turned on if any of the bit in the operands is 1. So if we see here two operands, the first bit, any of the bit is 1? Yeah, because first is 0, but the second operand, the first bit is 1. So first bit result will be 1. Now the second, if any of the bit in the operand is 1, both are 1. So then also OR will give us 1. Third bit, if any bit is 1, no, because in both the operands it is 0. So it will be 0. Now fourth, if any of the bit is 1, yes, B2 has 1 in the last bit. So it will be 1101. Let's verify our result. It is 1101. So now let's see XOR operation. It is similar to OR operation, just one difference that XOR operation will produce a result whose bits will be turned on only if exactly one of the bit in the operands is turned on. So let me display this, and let's say we do an XOR operation here. So what will happen in the first bits? Both are different. It will produce as 1. Second bit, if you see in B1 and B2, both are same. So it will produce as 0. And that is the difference between OR and XOR. OR will produce 1 here if both the bits are 1, but XOR will produce 0 because XOR will produce 1 only if exactly one of the bit is turned on. Third bit, both bits are down, so you will say 0. Fourth bit, it should be 1. So let's print this now and see the result. It's building. Yeah. So this OR operation produce 1101 and XOR produce 1001. Now the next set of operators are bitwise shift operators, and the first one is left shift. So let me print this statement first. Uh, Teacher to binary string. What we are going to do, B1 left shift by 1. Now when I say B1 left shift by 1, it means we are going to multiply this B1 by a power of 2, and this power is 1. So what will happen? You just have to shift the bits on the left hand side. And if you shift the bits on the left hand side, something you have to add on the right hand side, and it is 0. So we pad on the right hand side with 0. Now what was our value? 0100. If we do left shift, so this 0, the first 0 will be gone, like this 100 will be left shifted. So first 0 will be gone, it will be 100. And what will be here in the last digit? Because we have shifted these 100 by 1 on the left hand side, it will be padded by 0. So let's see this result. It is 100. Now, there's one more thing. Right shift operators or unsigned right shift. If the number is positive, then both the right shift and the unsigned right shift will produce the same result. Let's take this number b1 only, and this is a positive number. Let's say this, that we do a right shift by 1. Now our number was 0100. When we do a right shift, what will happen? This 0 will be gone. Like this 010 will come in the last 4 digits, and it will be, and we will pad with the zeros. If it is positive number, we'll pad it with zeros. Or like in this right shift operators, we pad with the sign bit. It is a positive number, sign bit is 0. So alternatively, it will be padded with 0 only. This last bit will be gone. So it will be like 010 in the last 3 bits here. And on the left hand side, we'll pad it with 0. So it should become 0010, and these initial two zeros will not be shown here on the screen, so it will print as 10. Let's see. Yeah, it is printed as 10. Now this is again a positive number, and as I said that for positive numbers, right shift and unsigned right shift both will produce the same result. So even with the unsigned right shift, it will be the same thing. It will print 10. See, it will print 10. Now, if you want to see the difference between right shift and unsigned right shift operators, let's take up negative number. How we can do it? Like in a simple way, let's say as int a is equal to -3. And to see how it is represented in binary, I'll do a quick thing. Like I'll just display this a using integer to binary string. So let me know what is a binary representation of -3. So this is the binary representation. It's printed. Let me give another number as byte b1, b3 as 0b as a binary number, and this number. Now let's do b3 right shift by 1. Now what did a right shift operator do? It shifts the bit on the right hand side and it pads the left hand side with the signed bit. Now this is a negative number. Negative number, so padding will be of 1. So this will be shifted on the right hand side. So this last one will be gone and the number will end with 0. And as it is a negative number, the left hand side will all be covered with 1 because all these bits are 1 and the sign bit is 1. So the padding will be done with the sign bit. So this should become something as 1 1 and up to the end, and it will end with 0. It will not end with 1 because we have right shifted with 1. Let's see this. So you can see here it's the same result, right? Now what is the difference between unsigned right shift and right shift? This was the right shift. If we do an unsigned right shift, what will happen? It will shift the bits to the right hand side, so the number will end with 0 because this 1 will be gone as we have right shifted with 1. But how it will start? Right now it's starting with 1 1, this sign bit. Now when you shift this one, what will happen? It will be taken as 0. But as here in IntelliJ we notice that it is removing this initial prefixed zeros. So ideally what you will notice, you will see this number, but this first one will be gone because actually it's replaced by 0, but in IntelliJ we just notice that the prefix zeros are not shown. So you will notice that the length is reduced by 1. Let's see this. Oh, let's probably print both, then I think it will be much easier to see. Let's see, let's do this by right shift and unsigned right shift, and in the unsigned right shift you will notice that the length is reduced by 1. So you can see this, that both numbers end with the same, but length is reduced because it is actually prefixed with 0, but IntelliJ isn't showing a prefix 0, so it shows as this. So basically, these are the bitwise operators, but just to know in practical purpose, personally, honestly, I have not used them in my projects. So it's actually used in embedded or like a bit low level programmings, but it's still good to know how these operators behave. So that's it from the practical side. That brings us to the end of this section where we discuss about different bitwise operators in Java, and also we did practical using IntelliJ. If you like this video, please hit the like button, do share it with your friends, and please subscribe to the channel. Thank you so much. See you in the next video.